Origo's privacy. Ethereum has advanced Bitcoin through a smart contract to make digital assets being directly controlled by a piece of code, which create possibility for more complex applications. Yet, current smart contract has no privacy. The input data to the smart contract and the execution result is public visible to the whole network, which limits the usage and adoption by many real-world privacy-concerned companies and individuals. While blockchain's powerful technologies have allowed interested parties to interact with each other securely and correctly, Origo strengthens that in addition to security and correctness, privacy is the key towards a broader adoption of blockchain. Although progresses like Zero Cash have enabled private transaction, Origo furthers such privacy work based on related research, such as enabling parties to create and execute a smart contract without revealing private input and output. While recent projects like Monero and Zcash have strived to solve privacy issues by creating new private cryptocurrencies, Origo aims to provide more privacy-preserving ability, not only confidential transactions, but also input-output data privacy for decentralized applications written in smart contracts. Therefore, Origo results much more complexity than those projects mentioned above. Then, Origo is more aligned with an enhanced Ethereum-like decentralized application platform which guards input-output data privacy of application. To address above limitations, Origo supports private transactions and smart contract. Here is a brief explanation of the four phases. In initialize phase, an executor from the network will be elected for later execution phase. In commit phase, each party will freeze their coins to the contract, and they will submit a commitment including their private input and coin. By using the commitment schema, the input and coin will be private, but the party can change it after commitment, after two parties have submitted the committed or the timeout of this phase has reached and the deposit has been verified. In the execution phase, each party will reveal their private input to an offline executor. Executor will execute the smart contract offline. In this way, the input and execution result will not be revealed to public. After contract is executed, executor will generate a zero-knowledge proof that the contract is executed correctly. Once the blockchain verifies the correctness, the fund will be distributed to each party based on execution result. By using this protocol, user input, transaction amount, and contract execution details are kept private, but everyone will still verify whether contract is correctly executed. Origo's privacy-preserving protocol enables broad adoption of decentralized applications that requires privacy. Origo classifies them in two categories. Privacy against public. In this category, participants want to keep input and output private from public, but they are fine to share this information between participants. Here are some examples of applications at each domain. In finance, rebate exchanges. In enterprise, salary bonus contracts. In healthcare, personalized medicine. And also IoT and many other use cases. Privacy against participant party. In this category, each participant wants to keep his input, output, and transaction amount prepaid from everyone else, so the full Origo protocol will be applied to satisfy the privacy requirement. Examples of such applications include fundraising, auction, and voting. Thanks for watching. If you want more information, go to origo.network.